Hi everybody, welcome to our lesson on 3.3. We're still trying to get all the vocabulary and foundational information that we need before we can start graphing lines. Um, so today we're going to be looking at function notation. And you'll notice here we don't have the typical start to a lesson showing. And that's because you need to use a handout to take notes today. And the handout is in Google Classroom for this lesson for 3.3. So make sure you print that handout out before you watch the rest of this video so you can fill it out with me. So today we're going to learn about function notation, which is basically another way to describe a function rather than using y equals. Because in upper level math, you're actually very rarely going to see y equals used. Instead, we're going to replace y with something called f of x, or h of x, or whatever else. And it's important to recognize this is not multiplication. F of x does not mean f times x. These are not separable. It's just a way of using notation. And the reason we do this is we're going to start getting into problems where we have lots of different functions within a single problem. And so if we always said y equals, we wouldn't be able to tell them apart. But if we use f of x and h of x and k of x, we can individually name each function. There's also some other advantages that we're going to get into here in a second. So just in terms of some pronunciation, so that you understand how this works, I have two functions here, y equals 2x plus 3, and f of x equals 2x plus 3. And I want you to notice that these two functions are the same. These are exactly the same thing. But they are looked at slightly differently. On one of them, you would read y is a function of x. Instead, for the one on the right, we're going to read it out loud as f of x equals. In the one on the left, I could ask you evaluate the function when x equals 3, which is a very wordy way of saying replace x with 3. With function notation, I can do this much quicker. I can just say find f of 3. And you'll notice that the 3 replaces the x, which is telling you to replace the x everywhere in the problem. Similarly, I could ask you to find x when y is 21 with the old way. With the new way, I could say instead find x if f of x equals 21. And we're going to go through an example of each of these together. So the first example we're going to do is I have a function g of x equals x squared minus 2x plus 1. And the problem is asking you to find g of 3, which means essentially evaluate the function when x equals 3. So the first thing I'm going to do here is I'm just going to copy down the original function, just so I have it. So g of x equals x squared minus 2x plus 1. Now the next thing I'm going to do is I'm going to replace all the x's with 3's, because I'm saying g of 3, and you'll notice that the 3 replaced the x. G of 3 equals 3 squared, and I'm going to put the 3 in parentheses to avoid any mistakes. So 3 squared equals 2 times 3 plus 1. And then all I need to do after that is just simplify the function. So I have 9 minus 6 plus 1. In other words, g of 3 equals 4. And what that's telling me is that when I make x 3, the input of my function is 3, and the output of my function is 4. Similarly, we can go in the other direction as well. So instead, I could say, okay, I have a function f of x equals 11x minus 3, and I want to find x if f of x equals 41, which is basically saying find x when y equals 41. So I'm going to copy down the function f of x equals 11x minus 3. Now this time we're going to replace f of x with 41, because we're saying f of x equals 41. So I'd say 41 equals 11x minus 3. From there, I just need to solve for x. So I'm going to add 3 to both sides. So I'm going to have 44 equals 11x. And then I'm going to divide both sides by 11 and end up with x equals 4. So this is saying when f of x equals 41, x equals 4. So on the back side of your note sheet, you're going to see a few different practice problems and 4 different functions along the top. I would like you to try this right now. Pause the video and see if you can fill out the entire back side of this worksheet, and then check your work with me to see how you did. All right, so for the first one, g of 10 equals, g of 10 would equal negative 3 times 10 plus 1, which equals negative 30 plus 1, which equals negative 29. F of 3, I would say, I'm going to plug in 3 everywhere into the f function, so I'd have 3 squared plus 7, which equals 9 plus 7, which equals 16. H of negative 2 would be 12 over negative 2, which equals negative 6. And j of 5 would be 2 to the 5th power, and 2 to the 5th power is 32. So then the next one, f of 5, I would do 5 parentheses squared plus 7, which equals 25 plus 7, which equals 32. Now, so find x if g of x equals 16. So I'm going to go to the g function, and I'm going to replace g of x with 16. So I'd say 16 equals negative 3x plus 1. So I'd subtract 1 from both sides. So 15 equals negative 3x. Divide both by negative 3. And I would end up with x equals negative 5. So then the next one, number 8, find x if j of x equals 8. So here we're going to say 8 equals 2 to the x. We haven't actually learned how to solve this algebraically yet, but you know that 2 to the 3rd equals 8, which tells you that x equals 3. And then finally, find x if f of x equals 23. And for this problem, I can plug in 23. So I'm going to say 23 equals x squared plus 7. I'm going to take away 7 from both sides, which leads to 16 equals x squared. And similarly, you don't necessarily know algebraically yet what to do here, but you do know that 4 squared equals 16, which tells you that x equals 4 for this problem. So this is how you use function notation in either direction. Now the last thing we're going to do in this video, you don't need to write down if you don't want to. It's not on your note sheet, but it would be good to pay attention and try this on your own as well. So we can also use a table of values to find different values with function notation. So for example, if I was looking at this table and I said, okay, find f of 0, I would look at the f function. I would find when x equals 0, and I would know that f of 0 equals 4. Similarly, if I wanted to know h of 3, I would look at the h function. I would look when x is 3, and I would know that h of 3 equals 1. Now, for number 3 here, find x if f of x equals negative 4. I'm going to look at f of x, but this time, I want to know x when f of x equals negative 4. So I'm going to find the f of x equals negative 4 spot, and then go up to x to find that my answer here is 2. X equals 2. Find x if h of x equals 3. I would do the same thing. So I would look at h of x, and then try to find the x value when h of x equals 3. So I'd come over to 3 and then go up to x, and I would find that in this case, x equals 2 again. And then finally find f of 0 plus h of negative 1. Well, if I look on here, f of 0 is 4, and h of negative 1 is 81. So if I add those two together, the result would be 85 for that problem. So this is how you can use a table to try to pick out different values for a function. And that brings us to the end of this video on function notation. So give the homework a try and let me know if you have any questions.